How do you solve a quadratic equation? Or how do you solve a quadratic function? Well, no. I mean, but how have we thus far solved these quadratics? We use two techniques. Okay. The first technique we used is called um, we factored it. Right? Do you guys remember that game where we played? We did like two parentheses like this, and then we factored it down and all that kind of stuff. We found two numbers that multiply out to be the number at the end and add up to be the number in the middle, and those are the numbers we choose, right? And that worked, and that worked pretty good for us, but didn't always work. You guys remember that? Like it wasn't that great, and so I showed you guys about this bazooka that we have, right? And we called that game completing the square. It was the one that will always work. It's just a little overkill, right? And that's the game that we played. Do you guys remember that game that we played where we took that number in the middle, and then what did we do? Yeah, we added. Um, you guys, you don't remember, or you do? Okay, we took the number in the middle, and we divided it by 2, and then we squared whatever we got, and then we added that. I'll go over that with you, right? So now what I'm going to do is I'm going to show you the third and super powerful tool. This one works all the time. It's also just like complete the square. It works all the time. In fact, all it is it's completing the square the quick way. Okay? And why did I go through a whole chapter of completing the square? And the reason being is because. Okay, wait. Someone's chatting to me. All right. Yeah, it works all the time. That's right, come on. Or Raymana. I combined their names. It works all the time, and the reason why it's so powerful. Why are you on your phone? Oh, okay. All right. The reason why it's so incredibly powerful is because it basically uses quadratic equations. Now, what is that? Okay. So I am going to show you guys this. I want you guys to write this down, and you guys will understand what I'm talking about in just a second. All right. So you guys can't see this. I have no idea why it's so blurry. Let's zoom in and see if that will help. Um, when I zoomed in, it gets blurry, but can you see it better though? Let's see. Is that all right? Yeah, that's not that bad. All right, let's try this. Okay. All right. So what we're going to do is we're going to look at this function right here. I want to try graphing that. So write that down. X squared plus 8x minus 1. All right. This is a warm up, and I know that you guys have been on break, so let's just kind of think about it. What is the y-intercept? In order to find the y-intercept, what do I do? X equals 0. So if I plug in x equals 0 into this thing, what am I left with? -1. Good. So the y-intercept is 0, -1. Are we cool with that? Kimilani? Is it Kimilani? It is? All right. Lemma? Good? All right. Now, before we do anything, by the way, I'm just curious to know, do you guys remember what form this is called? It's called standard form. It's kind of useless, but it is useful for finding the y-intercept. And it also will tell you one other thing. Does this thing open up or down? How do you know? Because the x squared doesn't have a negative in front of it. If the x squared had a number in front of it, like a 2, it would be a skinnier, but open up. If it were like a -1/3, it would be fat and upside down. Right. And that's That's how we know what's in front of the x squared. Like we look at the x squared term, and that's what will tell us it will open up or down, right? So I say it opens up. And if we were to graph this, try graphing this, okay? Just try graphing like what you think it might look like. By the way, the y-intercept is negative. The y-intercept is -1, 0, or 0, -1, and it opens up. So I would graph it something like maybe this. Right? Would you guys agree? Something like that. It could be different, but I know that it will cross definitely right here, and it will open up. That's the only two things I can really see from this thing, right? Is that all right with you? I'm like we're kind of doing the warm up thing, and so you guys kind of like, oh, okay, I'm remembering this. It's coming back. It's bringing back these horrible memories. All right. Lightly sketch the graph. Okay, all right. Here we go. So let's try factoring this. Let's see if we can solve this by factoring this. Because if we can factor this, then we can set y equal to 0. And why would we want to do that? To get x what? To get the x-intercepts. Exactly. Got it? So if we set this thing equal to 0, so write down 0 equals x squared plus 8x minus 1. What I want to do is I want to try factoring this. Let's try factoring this. Let's make our two parentheses. We good? Now this thing is way too fat for me to be able to really work very well on this. So I'm going to just go home, go to small size, and do that, and I'm going to do red. Okay, let's factor this. We'll put an x here, and we'll put an x here. Got it? Do we know it's going to be a plus or minus? Are they both going to be plus? Are they going to be both going to be minus? A plus and a minus. Good. Now, what two numbers can you guys think of? What are two numbers that multiply out to be the number 1? 1 and 1. All right. What are two numbers that multiply out to be the number -1 specifically? 1 times -1, right? Now, of that very, very short list, which one of those combinations can you make to add up to 8? No. And you guys are like, what? No. How can I mess with 1 and -1 to get 8 by adding them or subtracting them? You can't. You can't. This problem is like, what? That's just, what? How do you, what? Okay, so factored form, or factoring has failed us. This thing cannot be factored. So what do we do? All right? What is it that we can do in order to do it? We're going to use this very cool technique that I showed you guys like for 2 weeks before we left. It's called completing the square. I'll show you how to do it. Write this down. X squared plus 8x. And I'm going to put a big space and put a -1 there. We cool? All right. Now, why would I put a big space there? So that we can put the other. Because there's a number I'm going to add to there. Got it? Yeah. I got to figure out what that number is. And then, by the way, I don't want to change this equation. I don't want to change, like, I want it to look differently, but I don't want it to be a different equation. So not only am I going to add a number there, I'm going to subtract that same number as well. I'm just giving you guys a heads up, okay? So the question I have to ask myself is, what is that number I'm going to be adding? Do you guys remember? 16. How'd you get that? 8 divided by 2. You took the 8. That's this guy right here. Divided by 2, 4. Square that, 16. So I'm going to add 16. But I'm also going to subtract 16. Now, why would I add and subtract the same exact number? Because I don't want to change this. It's kind of like if I see you guys on Friday, right? Hopefully or if I see you next week, Wednesday. Hopefully between then and now, you would have taken at least one shower. And ergo, changing your clothes. So you would look a little different, right? Your hair might grow a little bit longer, and you would change your clothes maybe once. At least. Hopefully. But you wouldn't be a different person, right? So that's what we're trying to do. We're trying to change how this thing looks, but we're not trying to change the equation itself. Does that make sense? Okay. So, do you guys agree with, or do you guys understand every step that I took there? Now, the advantage of doing the big square, adding that random number 16 is this. See the first three numbers, x squared plus 8x plus 16? I can factor that. Let's factor that. I got an x here and an x here. X plus 4 times x plus 4. Do you believe me?
Yes.
If you don't believe me, FOIL it out and try it out for yourself. So really, you have x plus 4 squared minus 17. We cool?
Yeah.
All right. So this is x plus 4 squared minus 17. If I were to, I'm going to tell you that this right here and this right here are the exact same thing. If you don't believe it, multiply it out, simplify it, and you'll see that they're the exact same thing. They just look a little differently. Now, what is the advantage of putting it in this form, and what is this form called? Online, I'm looking at you. What is the name of this form, and what's the advantage of using it? You can find the x-intercept? Yes, you can find the x-intercept. Do you guys remember what it's called? What? It's called the vertex form. And why is it called the vertex form?
Because it finds the vertex.
Right. Remember when I showed you graphs like this, and these are like our favorite parabolas to graph? Because you're like, you look at that and you're like, oh, that negative 17, what does that do to my parabola?
Down.
Drops it down 17. That plus 4, what does it do?
It goes negative.
It moves to the left 4 because it does the opposite. That x, the horizontal one's a little funky, right?
And it's a positive.
The vertical one's exactly how it should be. The horizontal one is like, it does the opposite of what you think. You guys remember this?
Yes.
This game?
It's all coming back.
So where's the vertex? Where exactly is the vertex? Negative 4, negative 17. We can just look at that graph and read it. You guys got it? All right. So if we were to go back to our original graph and re-sketch it, I know that the graph actually it does cross right here, but its vertex is negative 4 and negative 17, so way down here. So the parabola actually looks something like this. That parabola still opens up. It still crosses at negative, or 0, negative 1. But it looks pretty different from what we guessed it to be. We cool?
Yep.
And this is the better graph. This is the more accurate graph. We cool with that?
Yes.
All right. And do you guys remember that process that we did, right? Like why I okay, good. Let's see. Because we're gonna have to later deal with square roots, and I want to show you guys where this stuff comes from. All right. Use the following quadratic equation for parts A, B, and C. All right. So here's what we're gonna do. You guys ready? Yeah, this is page 2. X squared plus 8x minus 1. Why can that not be factored? Well, because there is no numbers that multiply out to be 1 or negative 1 and add it to the 8. You can't factor it. That's the answer to that one. Alright, so let's solve this thing. Because You said that we can find the x-intercept with vertex form, and that's absolutely correct. We don't know how to solve for x in this case, but we know how to solve for x in this case. Pretty cool. All right, let's do it. Let's just do it. It's not even that hard. Write this down. X plus 4 squared minus 17 equals 0. We good? All right. I'm going to get x all by itself. How do I do that? Mitchell. I'll start off with you. Yeah. I'm trying to peel off the layers that are guarding x. On the outermost layer, there is the 17, and it's being subtracted, so if I want to put it over to the other side, I say add 17. Alright, so let's do the next one. X plus 4 squared equals 17. Are we cool? Alright. Someone online. What's the next step? You guys got it? What do I need to get rid of? What layer do I need to peel off here? All right. So do you guys know?
Yes.
Okay, well, what is it that I need to do? Tell me.
Both sides.
Square root both sides, right? So on the left side, I'll have x plus 4, because the square root will get rid of that square. But then on the right side, I'll have the square root of 17. Are we cool? You're missing a step. There's one small thing that you guys forgot. I'll show you right here. When you take the square root of both sides, you need to remember to throw in a plus or minus, right?
Yes.
Okay. And this isn't new stuff. This is all review. All this is warm up. I'm just trying to get your brains up and running again. We good? All right. Next part. We have x plus 4, or x plus 4 equals plus or minus 17. How do I get rid of the plus 4? I subtract it. So I have x equals negative 4 plus or minus the square root of 17. Now, by the way, at this point you're done. You just write that down. Negative 4 plus or minus the square root of 17. If you wanted to use your calculator and figure it out, I think that the square root of 17 is somewhere close to like 4.2 or 4.1. All right. So your answer would be negative 4 plus or minus 4.1. And if it were negative 4 plus 4.1, then what would it be? Like, let's consider the plus case. It would be just 0.1, right? And if it were negative 4 minus 4.1, what would it be? Negative 8.1. Right. So x-intercepts is 0.1 and negative 8.1. Pretty cool? Like, those are our two intercepts. So, if we were to graph that even better, it would be like right here. And 1, 2, 3, 4, 5, 6, 7, 8. It would be like right here. And then also, it would, the vertex would occur at negative 4. So that would be 1, 2, 3, 4. And down 17, something way down here. And so the parabola would look more like this. Are we cool with that? Like, that's just getting even more accurate. Yeah? You guys remember this?
Yes.
Okay, cool. Those of you online, you guys have been very chatty, and I think it's because I don't have my chatty students here, except maybe Raimana. You like to talk a lot. What's going on? Are you guys good? All right, that's fine. I'm going to... All right. So here's my warning. Before I get into what the quadratic equation is and how it works, I'm going to go over with you guys a little bit of things about the square root, just so you guys can remember. Have you guys learned square roots before? Have you learned about square roots? No, I don't think I've ever taught you square roots. You should have learned square roots back in Algebra 1A, I believe. So I don't know if you've. I don't remember if you've learned it. I know I didn't teach it to you because as soon as I taught you, I started teaching you guys about quadratic. I can start teaching you now. Yeah, it would be easy.
Here, I'll show you. Ready? If I have something like the square root of 8, okay? There's a way to simplify that.
Now, I'm not going to just plug into my calculator and get a decimal number. Okay, you can always do that. But the way you simplify that is you can
Think of it like this. The square root of 8 is really the same as the square root of 4 times the square root of 2. And by the way, just to let you know, there's this list of numbers that I want you to memorize. I'll tell it to you right now, and I've shown it to you before. This list of numbers is 4, 9, 16, 25. I want you to look at those numbers and just immediately think, oh, I recognize that. 36. What are those numbers? Right. Those are the perfect squares, right? And if I showed you a perfect square, you can immediately say, oh, hey, I know what that is. Like, if I showed you, like, 81. 9 times 9. Cool? Or if I showed you 100. Then the first thing you should think is,
oh, cool, that's a perfect square. You know, what's significant about the number, I don't know, 64?
it's a perfect square. Okay? So, check this out. Yeah. 49? Okay. Alright. So here's my question is, why do I break up 8 into 4 times 2? Yes, 4 times 2 does equal 8, right? So it's the same thing. I'm not changing it. But why did I choose the number 4?
Because 4 is a perfect square, right? So
really, the square root of 8 is the same as the square root of 4 times 2, right? Which is the same as the square root of 4 times the square root of 2. Right? It's not even that hard. What's the square root of 4? So really, the square root of 8 is 2 times the square root of 2. And that's the simplifying radical. That's what we call square roots. Okay? Is this hard? No, but see, this thing is, the calculator won't tell you this. They'll give you a number, a decimal number. But what they won't do is it won't give you this form. That form is it will help out a lot, significantly. And you know what? Yes. In my class? Yeah.
this homework assignment isn't just going to be like, okay, how well can you plug in things into your calculator? Yeah, that's true. That's true. And I'm not going to ask you to answer in decimals. I really don't. I mean, decimals is something that you guys will learn that, like, in math, you don't really care about. Yes.
Yeah.
Yeah. All right. So I changed up the course a little bit, and what I'm doing is I'm giving you guys. I'm still assigning it, right?
Yeah.
But in order to save you guys time, I'm like having to upload everything into Dropbox, like each individual Dropbox. I just made one Dropbox that you dump the whole thing in one time. That's why I'm doing it. So you still have your homework assigned, right? And I would still very, very, very highly recommend that you do it when I assign it.
Yeah.
But as far as
Do
when it's actually
until
due in the Dropbox, it's on that date that whatever I say, like whatever date I put all of quad 8 to be due. That's when you gotta throw it in. Is that cool?
That's dangerous.
And if you don't have everything, just turn in what you got.
Yeah. This is kind of a lesson in like.
Are you gonna really procrastinate? You guys haven't learned that lesson yet.
I may do that.
All right.
So maybe this is simple.
I'm just letting you know. All right. Anyway, hey, let's try the next one. Cool. Let's see. Let's.
Choose. I don't know. How's about the square root of 18?
The square root of 18. No, no.
Oh no! Wait.
The square root of 18. What two numbers multiply to 18? And one of those numbers should be a perfect square.
9 and 2. Good. Are we cool?
Yeah, we're not adding. We're not multiplying and then adding. All right. So what's the square root of 9?
3. So I can pull that out and this becomes 3 square root 2. Are we cool?
Yeah.
Alright. Let's try 48.
Square root of 48. Alright, the square root of 48. What are the two numbers that can multiply out that are
12 and 4.
Okay, cool.
12 and 4. So that's equal to the 4 I can pull out. And when I pull it out of the square root, I'll just square root it. So it becomes 2 times the square root of 12. Are we cool? It's kind of like reducing fractions. I'm teaching my fourth grader reducing fractions. No, well, I'm teaching my fourth grader
Like how to reduce fractions and whatnot. And then I ask him, well, are you
done? Is this the lowest you can go, or is there some more you can do?
So here's my question: are we done? Is 12 the lowest we can go, or can I keep on breaking that down? All right, let's break that down. 12 is
4 and 3.
4 times 3. There we go.
So it'd be 2 times the square root of 4 times 3. Are we cool with that? Well,
We can pull out the 4.
4, and so that would be 2 times 2 times 3, so it's actually 4 times the square root of 3. Do you understand where I got that 4 square root of 3? Brandy looks a little confused. Alright, fine. Let's do another one. Let's do the square root of 10. And by the way, Brandy, I'll explain to you where I got that 4 from. It would be really easy. I'll show you. Ready? No, wait, Brandy, let me show you this real quick. See that 2 right there? This right here is also 2 because the square root of 4 is 2.
2 times 2 is 4.
That's where that 4 comes from. Cool? Alright, square root of 10. So, what's our answer? Square root of 10? Yeah, sure. Alright, let's try this one. Square root of 50. Oh, fine, let's do that. Mitchell requested that one. Square root of 363.
Sure, you can use a calculator. Let's do square root of 363. It's kind of like reducing fractions. Oh, come on. Well, let me ask you this. What is the easiest one you guys can think of like that can divide this? Let's try 9.
Right?
Because can 363 be divided by 9? Or can it be divided by 3?
Yeah. Should be.
Yeah, you can divide 363 divided by 3, right? Because if you add up all the integers... Yeah. Alright, okay, so... But can I divide it by 9? That's my question.
I don't know. Try put it in your calculator.
Sure.
363 divided by 9.
Come on, Mitchell, since you requested, why don't you put it in your calculator? Alright?
Give us an answer.
Raimana, give us the answer. Wait. 363 divided by 9 is 40.3?
Okay. Try it.
Well, I guess
It doesn't work then, huh? let's see. Try divided by
64. That might be something. No good. Try divided by 81. I'm just trying stuff out. Well, I don't know if I want to try 12.
Why don't you want to try 12?
Well, I don't want to try 12 because 12 isn't a perfect square.
What about 16?
You can try 16 or 25. Let's try 4. Let's try the small one. 363 divided by 4. I'm wondering if that will work.
Doesn't work.
Ah, darn. Why did you choose such a stupid number? All right, let's try 16. I'm going to try one more, and then after that, I'm going to just be like,
Doesn't work.
doesn't work. Okay, good.
No. I'm almost curious.
You did 64, right? What else do we got? 64, we got 81. Hey, I got a question. Try plug in the square root of 363.
Okay.
Okay, never mind.
Alright. So the answer is,
It doesn't work. I'm cool with that.
alright. What if we do this?
Let's try the square root of 50. What times what will give you 50? And one of those numbers have to be a perfect square.
25.
25 and 2. Very good. Very good, King Long, very good, Brandon.
Square root of 25? Square root of 25 is...
I don't know why you use the calculator. Alright, are we cool with this? This game is actually pretty easy. Alright. Okay, I'm gonna move on. Alright, let's do the bottom first here. Let's talk about one or two of these, alright?
So what they're saying is...
Like, let's just do one of the problems. So we have this one right here. Square root of 48 times, or divided by 2, okay? First, what I want to do is I want to simplify the square root of 48 as best as I can. So, what is a number I can factor out
of 48? 4 and 12? Wait, didn't we play this game already?
That's why I was
And we already figured out that it's
4 square root of 3? Alright, so that. 4 square root of 3 is the square root of 48. And then this 4 will get cancelled out by that 4, and there's a 2 left over. So it's actually 2 square root of 3.
okay, thanks.
That's it.
Yeah.
That's how you do that.
Thank you.
Booyah. You guys get it?
Do the 200.
Alright. Because the reason why we're doing this is because I want to warm up for this guy right here. This is the most important part. Okay. Alright, wait.
What I want you to do is I want you to write this down. This is the most important part of my lesson. So, pay attention because this right here, please pay attention. This is why we did all of the work we've been doing for like 4 or 5 weeks. The whole point is to get you to this point right here so I can teach you the quadratic equation. Now, I'm going to tell you right now, the quadratic equation, when I first show it to you, it's going to look super hard. And it's going to look way harder
Just
than
like everything else did.
it's going to look harder than your actual homework is. But when you see how cool it is, how powerful it is, and how quick it is, you're going to be like, wow, that's amazing. Why didn't he show this to us at the beginning, earlier? And my answer is this, Most people do. Most teachers will show you this first thing. I think they're teaching this to the 7th graders. Right? Right. And the reason why people... Exactly. The reason why people hate this is because I can't really show you where this quadratic equation comes from until you understand complete the square. And so what they're doing to the 7th graders is they're teaching them quadratic equation and they're not showing them complete the square. So really it's just this crazy looking equation that they pull out of their butt and throw it up on the board and say memorize this for the rest of your life and use it, and you don't know where it comes from. So this is why I've been teaching you guys for the past 4 weeks completing the square and factoring and all that kind of jazz so that we can get to quadratic equation and you can understand where it comes from when I show it to you. Okay? And I'm going to prove it to you from scratch. And it might be a little bit like, oh my gosh, what's going on? All right? I want you to write down the steps that I do, okay? Let's try this. And you know what? I don't even have enough room on my thing, so I'm just going to start erasing. I'm going to erase some stuff over here. All right. Okay, there we go. All right. I'll delete some more of it. Okay, good. Yeah. I just made some room for myself. Alright, so I'm going to do this one. 7x squared plus 13x minus 1. And what I want you guys to do is I want you to write down the steps that I do.
Okay.
Okay? Write down the word, like the steps that I tell you to do. Okay? So step 1. I'm going to tell you what I'm going to do, and I want you to write down like why I did it. So write down the word step 1.
Okay.
And then start writing down. Okay, first thing I'm going to do. Step 1. I don't know how to complete the square when there's a number in front of the x squared term. So what I'm going to do is I'm going to pull that number out. So I'm going to pull a 7, and I'll make it x squared plus 13x over 7 minus 1 over 7. I'll give you a second. I want you to write down, write down what I wrote down and write down why I did it. And if you don't understand why I did it, make sure to ask me. I'm going to give you guys. Why did you do it? I did it because I want to pull out the number in front of the x squared term. The only way I know how to complete the square is if there is no number in front of the x squared term. But I didn't change the formula. Mitra, look at this. If I were to distribute this 7 back in here, right, it would be the same exact thing. So I didn't change anything. All I did was I pulled out a 7, and I'm just putting it on the outside. I'll deal with it later.
Okay.
We cool? All right. Online, do you guys understand what I did and why I did it? Okay, step 2. I'm going to just rewrite the same thing down. I'm going to do a couple steps here. I'm going to rewrite the same thing down, but I'm going to put a big space. I'll show you. 7 times x squared plus 13x over 7 minus 1/7. Close parentheses. I didn't change anything. I didn't really do anything. All I did was I put some random spaces. And Brandy totally got it. Brandy's like, oh, I know what he's going to do if you put the space in there.
But
Like it's obvious. I know what's going to happen.
when you put that complete the square part in there, don't you have to divide it over 5 by 7 into 4?
What is that?
When you put in a number, the other number, does it have to be divided by 7?
Yeah, because the number I'm going to use now is not a even number. I remember you asking me when I complete the score, what happens if it's not an even number? You just do it. You deal with it. You know what I mean? So this one's not only not an even number; it's a fraction. All right, it's ugly. Okay, fine, but let's just do it. So that's 13 over 14 squared. Right? That's what I want to add. So I'm going to add 13 over 14 squared. And by the way, I'm going to subtract. What is 13 over 14 squared? Do you guys have a calculator? What's 13 squared?
What is 13 squared?
I think it's like 169.
So it's 169
Divided by, what's 14 squared? 14 squared is like 180 something. Was it?
No, I did 42. Hey, 42 is 14. Same as 13 squared.
196. There we go.
169.
Over 196.
All right. Diamond saying that you're lost. Why are you lost? What's going on?
I just wasn't.
Okay.
Where did I get 13 squared over 14 squared? Okay, I'll show you.
Ready? All I did was. All right.
What is the steps? What is the process? I take that number in the middle,
Yeah.
I divide by 2, and then I square it, right?
Yeah.
Dividing by 2 is the same as multiplying by 1/2, right?
Yes.
So it's 13 over 7 times 1/2. 7 times 2 is 14. That's where I got that from. And then I squared it, and that's how I got this ugly number 169 over 196.
Okay.
We cool?
Yeah.
I'm not doing any
Magic here. I'm not really doing anything like super secret here. They're just ugly numbers. You guys. But I mean, you see what I did, right? And by the way, step 2 is called completing the square. That's what we did, right? All right. And so these first 3 numbers can be factored. And it comes out to be x plus 13 over 14 squared. I guess this is step 3. I still have my 7 out in front of everything. And by the way, I have minus. Oh, goodness.
1/7 minus
169 over 146. Or 196. What is 196 divided by 7?
I want to combine those fractions.
Did you say words?
28. Okay, so this is really 28 over 196, right?
Yes.
Right? So if I add 28 plus 169, I get, easy calculators,
Now remember, this isn't hard stuff. It's just ugly numbers. What is 28 divided by plus 169? 141? Wait, 28 plus 169?
There's a negative in front.
that's a negative 28 plus a negative 169. So you add those. 190 what? 190.
197. Yeah.
What?
Are we cool with that?
Yeah. Hold on.
All right.
And then the last thing I'm going to do,
Okay, wait.
keep learning. I'm sorry, I missed when you asked
Ask me exactly, how did you get that? How did I get what? One 197 over 146?
Okay. I got that. I got that by doing this, Kimilani. Negative 1/7 minus 169 over 196. I'm sorry. Yeah, it's not a 46, it's a 96. Alright. I got that from negative 1/7 minus 169 over 196. What I need to do, and this is like 4th grade stuff, if I want to add 2 fractions, I got to make the denominators the same. So 1/7 is the same as negative 28 over 196 minus 169 over 196. Do you see what I'm doing now? And now that I have the denominators the same, I can just straight up add them. Or in this case, subtract them. Or add the negative versions of them. Does that make sense? So, negative 28 minus 169 is, as Mitchell told me, 197 over 196. We cool?
Yes.
The last thing I'm going to do is one more step. This is step 4.
I'm going to distribute that 7 back in there. I'll show you where I'll put it in. I'll put it into here, and I'll put it into here. So this becomes x plus 13 over 14 squared, there's a 7 out in front, minus 197 divided by 28. You see what I did? Okay. Do you got this process? Let's recap it. Let's recap it, all right?
Now, remember, this is the exact same thing we've been doing all along. The numbers are a lot uglier. Okay, fine. But it's the same process. So remember this process, all right? Because I'm going to show you guys. And it's going to, when I show this to you, hopefully it will be like, wow, that's so cool. I understand what's going on.
Somebody left the meeting. Someone's like, I'm done with this. All right.
All right, so here's what we do. We started off with this right here. That's our first equation. That's the equation they gave us. Okay? Step 1, what did I do?
You took away the 7, so divide the 7.
I pulled out the 7 so that I can not have a number for an x squared. Step 2, what did I do?
I completed the square by putting a big space, taking that number in the middle, dividing it by 2, squaring it, and adding that. And I also subtracted that same number as well. Because I don't want to... Why did I add and subtract the same thing? Because what? Why did I add and subtract the same number?
Because what you do to one side, you gotta do to the other.
Right, because I don't want to change the equation. I just want it to look differently. All right? And then completing the square, you guys know how to do that. That was step 3 as well. I factored it.
On the fraction on one,
And then step 4 is just simplify it. Simplify the rest of it. Are we cool?
fraction on the end.
Yeah.
Is it 197 if 7 over 1 multiplied by 197?
No, I see what you mean. What Diamond is asking is, where did I get 197 divided by 28? Is that what you're asking me? Okay. Here's what I'll show you what. I got it from 7 times 197 over 196. I'm multiplying these two together, right? But before I multiply, let me reduce everything I can. And I know that 7 goes into 196 28 times, because that's what you told me. So that's where that comes from. You guys see that? Now I'm glad you asked. You're making sure. You're verifying that what I'm doing is absolutely correct. I appreciate it, because half the time I'm wrong, and half the time I'm really just kind of like seeing whether or not you guys understand this. Cool? All right. But the important part here is this. Do you understand the steps?
Do you understand the process?
Now, by the way, this is what we're going to do now. And it looks horrible. And remember what I told you? There is...
It will look a lot worse than it actually is. Let me show you.
I'm going to delete that. I just deleted it. I need more room. Boom. Let me go through with you guys how to
Solve the quadratic equation.
where we get it from. Because once you guys get it, this will blow your mind. All right, let's do this.
Hang in there with me. Ready?
All right. First thing I'm going to do is this. I'm going to solve this equation. Write this down. I want you guys to write this down, and all of the steps that I did in y did. I'm going to solve out ax squared plus bx plus c equals 0. Now this looks a lot like the problems we solved before. It looks exactly like standard form. In fact, it is exactly standard form. The only difference is instead of a bunch of numbers, I gave you a letter instead. Like, for example, do you guys remember the first problem we solved today was 1x squared plus 8x minus 1 equals 0, right? In this case, the a is what number? What number is a? What number is b? And what number is c? Maybe 1. But I don't want to solve just that one equation. I want to solve all equations. So that's why I'm using letters instead of numbers. Okay? That's all I'm doing. Alright, so we'll start off with that. You guys have that written down? Good. Step number 1. I'm going to pull out an a. So I have a times x squared plus b over a times x plus c over a equals 0. Are we good?
I want you to write this down. And I'll give you a second to write down why I did it. Do you understand why?
By the way, make that online, I need you guys' response.
What's going on?
Do you see this? Alright, so, tell you that, right? Now what I'm going to do is I'm just going to rewrite the same exact line. So this time, I'm going to put some weird spaces in there. A times x squared plus b over a times x plus c over a equals 0. I didn't change anything. I didn't do anything. I just put some weird spaces. Ramana and Kimilani, I need you to respond. Alright. Ramana? Okay, good.
Alright.
So we good so far? Yep. What do you think I'm going to do next? Complete the square. So I take that b over a, I divide it by 2. What does it become? b over 2a. Exactly, it's b over 2a. That makes perfect sense, right?
And then I square it.
So if I square it, that will become b squared over 4a squared. You cool?
But I don't want to just go around adding b squared over 4a squared.
I have to subtract b squared over 4a squared.
Are we good?
That's fine. I'll wait.
The advantage of
Completing squares. These first 3 times right here, I can factor that. And that becomes x plus b over 2a squared. I gotta put that a out in front. And I still have this plus c over a minus b squared over 4a squared. What was it underneath the b? It's 2a. I'll rewrite that. 2a. Cool?
and if you
Don't
don't
believe me, what do I always say you can do? You can clear it out and then you'll end up getting the same thing, right? But But you believe me, right? Because I mean, it's always worked so far. Yeah? Alright.
I'm gonna do one last step.
And then I'm almost done.
Almost.
Okay. I'm going to get rid of that. I'm going to multiply in that A again. So I'm going to put it into this term, and this term. If I put it into the first one, I just put an A on the front. Got it?
What are you doing?
You don't need a calculator. We're dealing with only letters here. If I multiply C over A by A, what do I get? C over A times A is what? Just C. And B squared over 4A squared times A is what? B squared over 4A.
Just A.
Why is it just A and not A squared?
Because you took away that A. You took away the square by multiplying that A.
Because there was another A on top that got cancelled out with one of the ones on the bottom. Are we cool? And that equals 0. Congratulations, my friends. We have just put this into vertex
Form. Look, it's in vertex form.
I know. It looks ugly. But we just did it. We put it into vertex form.
What is that fraction?
The B squared over 4A? That is actually a pretty cool fraction now. We'll explore that. It's called a discriminant. That's what it's called. We give it a name. But for the most part, look, we put it into vertex form. Is this very useful to us? Does it look very helpful? The answer is I don't think so. It looks horrible. It looks horrible. So I'll tell you what I'm going to do. I'm going to work on it just a little bit more. Hang in there with me. But I'm telling you, we're almost done. Alright?
Remember, I told you this was the hard part. And once I give you this equation, you'll understand where it comes from and you can use this thing with confidence. All right? Now, all I've done is complete the square. That's all I've done. I haven't done anything magical. I've just been using this trick that we came up with, completing the square. And all that is meaning take that number in the middle, divide it by 2, square it. And where did that come from? I didn't even tell you to do that. You guys told me to do that. Remember, I made you do a whole bunch of these perfect square things? Do you remember when we were doing that observation and you did that perfect square thing? I made you do a whole bunch of those things?
Yeah.
And you guys told me, hey, wait a second, that's just dividing by 2 and you square it.
Yep.
I see the relationship. That's all we're doing. We're just drawing and stuff you already know. All right, okay, you ready? Let me finish it off.
What I'm going to do at this point, and this is what I didn't do in the previous one, is I'm going to solve for x.
I'll do it for you.
You write it down. Ready? I'm going to solve this for x. To do that, I'm going to take all the stuff over here and move it to the right-hand side. Okay. Well, why don't you wait till I finish before you take a picture? Alright. So, what I'm going to do is I'm going to have a times x plus b over 2a squared equals b squared over 4a minus c. That would be a 2a. It's 2a. It's always been a 2a under the b. Oh, underneath the b squared is 4a. Yes, I'm sorry. Okay, fine. I'll miss it. I'll rewrite it. 4a. 4a. Oh, okay. I don't.
Yeah, all right.
At
4A.
the end of the movie,
Yeah.
Johnny Flame in there.
All right, are we cool with this?
See, all I do is, what do I do? You guys see that I'm doing this right?
Yes. Move the other things to the other side. So you have the positive fraction and then you have the negative sign.
Yeah. I subtracted c, and I added b squared over 4a. That's all I did. I just moved it over to the right hand side. Okay? What I'm going to do before I deal with this, I'm going to combine these fractions, if that's all right with you. I'm going to make this 4a over 4a. Right? Now, why would I do that? So that I can, so c times 4a, so I can make it into a big fraction. Since there's two of the same ones, then really this becomes b squared minus 4ac all over 4a equals. Brandy, you look scared. What did I do?
No, but what did I do in math? Look, not what did I do to scare you. What step did I do and why did I do it? All I did
Was I just wrote this as, I don't know, we had the same denominator in these two fractions up here. So I just put it over the same fraction, right? That's b squared minus 4ac. I'm sorry, I wrote c4a as 4ac. It's the same thing since it's all being multiplied together anyway. I just like writing the numbers first and then the letters in alphabetical order. That's all I like doing. Alright. Okay, wait. Let me finish this off. You guys ready? Let me finish this. I need x all by itself. I need to divide out that a out in front. Okay, that's fine. That's easy. X plus b over 2a squared equals b squared minus 4ac all over 4a squared. Well, I'm not going to do, what I meant is I'm going to deal with this a over here. Yeah, so I divided out by a. This right here is one whole term. So I divided this whole term by a, and I divided this whole thing by a. And all I did was made this thing right here 4a squared on the bottom, instead of just 4a on the bottom. Pretty cool?
I'm almost there.
I'm almost there. I'm going to get x all by itself. How do I get rid of something that's around us? A square root of it. Very good. So I have x plus b over 2a equals the square root of b squared minus 4ac divided by
The square root of 4a squared. What's the square root of 4a squared?
2a. Oh, gosh. I'm sorry. I have a student named Carmana as well. And my aunt has a dog named Carmana, so it's a little bit tough. Alright. Kimilani, do you get it? Have I lost anyone yet? I know it's tough. I know it's struggle. Struggle your way through this. Alright? Seek your way through this. Because it will be worth it. I guarantee you. It will be worth it. Okay, here. Ready? Alright. Alright. I'm going to do one more step. One last step. I'm going to subtract b over 2a onto the other side. Now I'm going to deal with that b over 2a. So I have x equals negative b over 2a. By the way, there's one thing I forgot. Plus or minus the square root of b squared minus 4ac. All over 2a. But I'm telling you, the one thing I forgot is that plus or minus. No, well,
I wanted to make sure I went that. What I didn't do was I didn't add in that plus or minus. And you guys know where that plus or minus comes from, right? Because when I took the square root of both sides, I need to throw in that plus or minus. Right? By the way, we're done. I'm just gonna write this down a little bit prettier and we're done.
Since it has the same fraction, here's how I write it down. Negative b plus or minus, yes, we can absolutely do it with actual numbers. The square root of b squared minus 4ac all over 2a. I'll just put x equals, this is the quadratic equation. Write that down. When you write this down, you're going to be like, alright, so right now, I know, okay, fine, alright. I'm going to show you guys a cool way to remember this, alright? Because I do want you to memorize this equation. That's how you memorize it. Alright, so I'll tell you the story. Here's the funny story that I know. Okay, ready? There was this dude.
He's a boy.
Sure. Sure. Let me scroll up just a little bit.
Oh no, no.
Randy wants to like say, "Oh my gosh, look what we did in that." Here, you want to scroll down and get the bottom part? Okay, all right. So let me show you. All right, let me tell you guys how I memorize this. Okay, ready? There's this boy. He's a negative dude. He's negative. That means he's not. He's not a happy
Parabola.
He's a sad problem. Okay, ready?
He was invited to this radical party, but he was unsure of whether or not he wanted to go. By the way, does radical still mean radical? Like, what does radical mean to you? Like, because back when I was like,
ridiculous.
All right, fine. He was invited to this rad party.
Okay.
All right, okay, fine. He was invited to this rad party. The dude was kind of a square at the party. What does that mean? Because back in like, he's like very what, like rigid, like what, like bow tie and button down shirt and tucked in your shirt and that kind of stuff. Is that cool? All right, no. Wait, you're getting the story mixed up. Negative boy. He was unsure if he wanted to go to this rad party. At the party, he ended up going. At the party, he was a complete square. And because he was a complete square, he missed out on talking to 4 awesome chicks. Okay? And the whole party was over at 2 a.m. All right, tell me the story. Tell me the story. Negative boy.
I wasn't sure.
Unsure. I'm just picking out points here. Negative boy, unsure.
We should go to a
Rad party.
and then
Yeah. He was a square. And because he was a square,
he missed talking to 4 chicks.
4 awesome chicks. And this entire party was over at what? 2 a.m. All right, take it out. Ready? Negative boy. Negative boy. Unsure. Negative B. Unsure. Plus or minus. Of going to this radical party. By the way, the square root is known as a radical in math. It literally is. The boy was a what? B squared. And because he was a square,
He missed talking to 4
he minused out on 4AC. And this party was over 2 a.m. Yes! Now I have outlined the story so you remember this. But guess what? That's it. That's the quadratic equation. Yeah.
It was awesome.
All
right. Now,
I've heard multiple things, but anyway, I want you to memorize the quadratic equation. That's a good way to start. There's songs, there's, I don't know, things, dances or whatever. I've never seen a dance, but anyway. The quadratic equation dance. Alright. Let me show you, like, the power of this thing and how it actually can work. Because when you guys see it, you'll be like, oh, wow. let's try this one. Which kind do I want to do? I want to do that one.
Does it gonna have numbers?
It is. It's going to totally have numbers.
Wait to it now?
Yeah, totally have numbers. I just, for some reason I can't find it, but I'll just make it. Oh, here we go. This is the one I want to do. Okay, let's do this one. X squared plus 8x minus 1. I'm going to write down the quadratic equation because I'm almost done. Come on, let me finish. Ready? Brandy, I need you to write this down. Give me that phone. Just for 10 minutes. Give it to me. Now. Okay. You ready? I'll write down two things for you and hopefully remember that. First thing is this. We use the quadratic equation on equations that look like this. ax squared plus bx plus c equals 0. When we have a situation like that, quadratic equation. And what is the quadratic equation? It is x equals negative 4 plus or minus radical
So the end of 1 is a square.
e squared
Yeah. We use that negative 4
4ac.
and the party ended at 2 a.m.
What is that? That's crazy. That was only like a couple years ago. Alright, so here's my question. What is A in this case? What is the number for A? Diamond wants numbers, I'm giving you numbers. A is 1. What is B? 8. Good. What is C? Negative 1. Awesome. To use the quadratic equation, all you do is you take that A, B, and C and fill it in. And you know what that does? That does that whole complete the square thing right off the bat. That's what it does. It completes the square for you by just taking numbers and plugging it into this crazy looking equation. You've completed the square. Because remember, how did we get the quadratic equation? We completed the square. That's all we did. We just did it on a nightmarish looking thing because there was a whole bunch of letters. But we use those letters so now we can change up whatever those letters represent. And in this case, for this particular problem, A is 1, B is 8, and C is negative 1. All right, fine. Let's plug in our numbers. X equals negative 8. Equal? Plus or minus the square root 64 minus... Yeah, 64.
Okay.
Well, 8 squared. 8 squared is 64, right? 4 times 1 times negative 1. Negative 4. So it's actually minus negative 4, which means plus 4. Are we cool with that? Divided by 2. Because 2 times 1 is 2. We cool? Right? So this would be negative 8 plus or minus the square root of 68, right? Divided by 2. We good? 64 plus 4 is 68. Well, the 2a is 2 times a, which a is 1, so it's just 2. No, this is... Oh! No. This is the way the book writes it. This is the way I wrote it. The difference between the book and this is, here's a 2a over here and 2a over here. I noticed that those are the same denominators. So I just put it over one giant 2a. Does that make sense? Yeah, alright. That's the only difference between those two. Alright. By the way, square root of 68, is there any way that I can simplify that a little bit? Like 68, can that be divided by any perfect square number? Well, if it's even, let's try 4. 4 times what gives me 68? Hopefully it's a number that's nice. 4 times.
Okay.
What is it?
4 times
17.
what?
It's 4 times 17.
Good. So this is really negative 8 plus or minus the square root of 4 times 17 over 2. I can pull out that 4 out of that square root, right? So it's negative 8 plus or minus 2 square root of 17 over 2. And now what I can do is, since I can divide 2 into the 8 and 2 into the 2 over there, I can simplify this as negative 4 plus or minus the square root of 17.
Are we cool?
Which 2? This
2 right
here, this 8 became a 4. I divided the 8 by 2, and I divided by the 2 square root 17 by 2. You see what I mean? That in the box is our answer. Take a look at the first problem I had you do today. Go back to the first thing you did in your notes. What was the answer?
Minus 4.
It's the exact negative 4 plus or minus the square root of 17. Did we use complete the square? We did the first time. Did we have to use it this time? No.
We just
Plugged it into this ugly equation. And the equation did the complete the square for us. So now you have,
I showed you the bazooka of complete the square, and it's a lot of work, right? But now we have the quadratic equation, which it was a lot of work to get, I admit, right? And there's a lot of steps, or there's a lot of, the equation's kind of big, but it always works because it's
drawing on complete the square.
we use it to do complete the square really quickly. Does that kind of blow your mind? Like
How cool this actually is?
look.
Like I said,
Your homework is
as far as what was up on the board. Your homework is not, I'm never going to ask you as a 9th grade student to prove the quadratic equation. On a quiz, on all that kind of stuff. I might ask you to do it as a project, as a homework assignment, and write out all the steps. You know, you'll have all the time you need. But I'm never going to ask you
on a quiz. Prove the quadratic equation. That's not going to be a homework assignment. That's not going to be all that kind of stuff. All it is just going to be use the quadratic equation. It was difficult today because I wanted to prove it to you. And most of the time, we don't. We as math teachers don't prove it to you. We just show it to you. Because it was complicated. It was tough. But it was worth getting. Because now we have this tool. We've got this weapon that we can attack any quadratic function with and get the answers without having to complete the square, without having to factor it. You guys realize that this weapon can replace factoring and completing the square. Now, I admit to you, sometimes it's easy to factor it. If it's nice numbers, you know what I mean? I just factor it. That's what I would do. But if you can't factor it and you're like, oh, I got to complete the square, well, instead of having to complete the square, just plug it into negative b plus or minus the square root of b squared minus 4ac all over 2a.
What about number 5 that doesn't have a C?
Which one?
The last one.
This one right here?
Yeah.
Okay. So a as well.
1, B is 1. 2, C is 0. Okay, fine. So it's negative 2 plus or minus the square root of 4 minus 4 times A times C, which would just be 0. Okay. Divided by 2 times 1. Alright, so it'll be negative 2 plus or minus 2 divided by 2. Okay, so that's negative 1 plus or minus 1. So the answer is either 0 or negative 2.
If I were to graph,
This parabola right here, it would cross at 0 or negative 2. This parabola looks like it will open up this way. So good. That's how you use the quadratic equation. Alright, fine.
I think that's fair because the teaching thing makes it look so terrifying. So when we actually do the variables, like the ways,
Now, if I could do it without,
if I could teach you,
if I could prove to you the quadratic equation without the numbers or without the letters, I would. If I could feel comfortable with just starting off our lesson. So what I could have done today, and I could have started off the whole lesson with, all right, folks, from now on, I'm going to introduce you to this equation. It goes x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And you use it when you have an equation that looks like this. Any questions? And you'd be like, where does this come from? Never mind where it comes from. Don't worry about where it comes from. Just use it. Why are you telling me to use that? Why should I trust it? Because it's magic. I'm frustrated like magic. And I'm the math teacher, and I know what I'm doing. I could have done it. I totally could have done it.
what I'd rather do is spend 4 weeks teaching you to complete the square, so that when I finally introduce
To you, here's the quadratic equation. You understand. That's where it comes from. I know why I'm doing this. And it's not just a thing that you use. Anyway, I got physics students in here. Let's get this part started with them. Okay, I'll see you guys later.
I'm going to stop the archive. Hopefully everything works.